This section is all about exponential growth and decay. We've already kind of worked with exponential growth and decay. When we were talking about the money situation and using rates and time, for instance, when we had an initial deposit and then we wanted to figure out how much money would be in our account after X amount of years. So we've kind of already dealt with this a little bit, but this is that formula that we had. It was A equals P to the E, P times E to the power of RT. And it's similar. This is more of a generic form of it. So by that I mean we have y equals n e to the power of kt. Okay, y is the final amount. Okay, so if we're comparing it to the a equals p to the pert, a was our amount after. It's the same type of concept. Y is our final amount. N is your initial amount. That was our initial deposit before. E is always what we're dealing with anyway. K is our rate, or it's some type of constant number, whether that's decaying or growing. It just kind of depends. We'll just leave it as constant. And T is time. Now, before, when we were working with it, time was always in years. This could change. They'll let you know based on the examples whether you are working in days, hours, years. They'll let you know all that information up front. But the good thing is we kind of have had some practice with this before you guys have been given some questions regarding it. Someone might be thinking, okay, when am I ever going to use exponential growth? When am I ever going to use exponential decay? So you could be using exponential decay when you're talking about a fossil and how much that bone actually decays or the body decays, okay? Exponential growth, we're growing exponentially. So for instance, if in the school someone has a cold or so they're sick, they have sick germs, the exponential growth could be the germs going throughout the school and how continuously they are growing in numbers. Okay, bacteria and germs are a good one for exponential growth. So for instance, let's say that K is negative 0.377. T is what we're trying to find. This is going to be n days. 500 is going to be the final amount. 200 is my initial amount. Okay, so to start off with, I'm going to go ahead and plug this right into my formula. So y equals ne to the power of rt. Y was 500, n is 200. My rate, or not my rate, kt. So it's negative 0.377, and we're trying to find t. So you should be looking at your notes from a couple days ago about this. With that being said, we know that we're going to have to divide by 200 to get that simplified. Well, 500 divided by 200 is 2.5 e to the power of negative 0.377t. All right, because we're dealing with e to the power of something, we're going to be looking at the logarithm, a natural log. So with that being said, I'm going to take the natural log then of both sides. And we know from previous experience that the exponent for the natural log of e can actually be moved to the outside. We also know that the natural log of e is just 1. Well, how am I going to get that t by itself? I'm going to divide it then by negative 0.377. And that'll give me my t in days. When I type this into my calculator, I get negative 2.43 equals t. Now, something to note, the reason why it's a negative is because this is a decay. That's all that negative means. So realistically, it's going to take 2.43 days. Okay. Let's say that I am trying to find my n. Y is 500. N is what we're trying to find. K equals 0.0034. And T is 4 years. You should be able to figure out and solve for n on your own. Go. Looking at this, I'm going to plug it right into my formula. You should be able to figure this out on your own because we've done this example, something similar to it. So I'm going to go ahead and simplify my power there. And I know that it's e to the power of 0.0136. Okay, remember when we had the n and the e together, we broke it down based on our properties of logs. I'm going to combine two steps here. I'm going to break down this n to the e to the power of 0.0136 as well as put the 0.0136 on the outside because we already know that's going to happen. So now I know this is the natural log of 500 equals the natural log of n plus 0.0136. I know a natural log of e is, it actually just eliminates. So I'm going to move that over. ln 500 minus 0.0136 equals the natural log of n. I know this is an anti-log, so I know that it's e to the power of the natural log of 500 minus 0.0136. So I'm going to go ahead and plug that in. Notice my parentheses, I have to close them. A lot of people were struggling the other day with how to figure that out. N therefore equals 493.2.